Yeah, L3 Harris, our division of L3 Harris is autonomous surface vehicles, and we have over 450 autonomous vehicles in the field. Previous to being acquired by L3 Harris, ASV, um, we the same group of people had years of experience in underwater autonomous underwater vehicles as well. So years and years of experience with control and automation of these things. Uh, we are doing we have commercial work, and we're also doing numerous Navy programs that um, you may have heard of, uh, becoming a DoD contractor with the, 303 Harris. So we are deploying many control systems on many different sizes of vessels, and different vessel applications, such as oceanography, um, getting defense weapons, tracking, surveillance, and those types of things. So next slide, please. So yeah, so we started using Bedrock and with CODESYS. Recently, we do have lots of experience with CODESYS in the past, so it has been very beneficial to for Bedrock to have CODESYS along with all their benefits with the cybersecurity and rugged PLCs. Some of the benefits are, as you see on the screen, seamless integration of SCADA, standardized Familiar IDE, which is great for, like I said, Marcus coming over and having that experience with CODESYS already has been great. Object-oriented principles and being able to reuse code and package small chunks of code and put in different places. We have many different applications and many different, every boat's different, right? So every piece of code needs to be configured in a slightly different way, and CODESYS lends itself to that for us with object-oriented programming. Redundancy, downtime is not really an option for a lot of our applications, so redundancy is a must. And then Bedrock and CODESYS make it extremely easy to have that easy, seamless failover redundancy. Next slide, please. So yeah, our biggest application with Bedrock right now is shipboard machinery control systems, and that would be, we'll get into more of those details later, but basically controlling the boat and the maneuverability of the boat, propulsion, everything that has to do with engineering operations, or maintaining and running the boats. So we've definitely moved more in the from hardware based to software based logic. We're doing everything on HMIs now and touch screens, and big space saver there, big space saver with control cabinets for being able to get more software based logic into the system and avoid more relays, push buttons, and things like that. So requirements definitely have evolved from doing custom circuit boards and things like that to commercial off the shelf is a big push for the Navy, and so having this available to us, and then also the not having as many licenses to keep up with and things like that is really a big benefit. So next slide, please. So here's an example of our of an MCS system that would drive a boat. So you can see we have everything from navigation to propulsion and auxiliary thrusters and ballast management, cargo management, alarm monitoring. Lots of different payloads could be interchanged on a lot of the vessels, so we have to accommodate various payloads, and On the right side of your screen is a example of like an HMI of an interface, excuse me, and showing all the different various controls and monitoring that we are able to do. So lots of inputs and outputs, lots of pieces going into it. And yeah, and so we have capability here to do touchscreen, to bring up alarms, to have all in one place, on the HMI, and also be able to distribute the control system across the vessel, and really increase survivability and reliability, in having multiple controllers across the vessel, and that was a big benefit for going to Bedrock. So that, for example, if we have a controller and one set of controllers, however redundant it is, it's one set, and it goes down, you lose the whole vessel. Having multiple controls distributed across the vessel, maybe you can have one engine room, lose that engine room, and still have your other engine room and be able to drive the vessel. Next slide, please. So here's this is one of our commercial vehicles that does some oceanography, underwater tracking of like ROVs and things like that. So really, there's not as much redundancy here, but there's this is a small vehicle, but it has many different, the same capabilities as and the same needs as the bigger vessels, and the propulsion and the steering, heading, communications, taking in all the sensors. And so this is a typical vessel right here that we do for commercial applications and have a centralized control system in. Next slide, please. And yeah, so Bedrock and CODESYS, checks off all of our requirements and considerations we take in, especially high reliability, commercial off the shelf, modular code configurability, phone life support, remote diagnostics is great. Having the standardized IEC compliance is wonderful, and it'll help us carry over to wherever the future takes us, and hoping to keep that same standard going forward, so that it's not heavy recoding for us. Also, yeah, harsh environments are big on the hardware side. Having that ruggedness and having being able to put things in an engine room, like I mentioned earlier, it is big for us, and having that local control. And so I think that's it. If we go to the next slide, I believe I'll pass it over to Craig and Marcus.
Hey, so this is Marcus Savini. I'm going to talk a little bit about seamless integration into SCADA interfaces such as OPC UA. Next slide, please. So this is one of my favorite graphics. So as Raya mentioned, cybersecurity is a huge consideration for us. So it's very secure on the hardware to the firmware to the software. If you kind of dig into the graphic a little bit, they have a hardened operating system, pinless interconnect, anti-tamper capabilities. So yeah, it's super secure, and one of the reasons we chose to go the Bedrock route. Next slide, please.
Okay. Thank you, Marcus. Thank you, Raya. As Marcus just mentioned, Bedrock has the layered level of security, focusing on just one level of that, being the secure communications. One major component Bedrock uses, CODESYS uses, and L3 is also using is secure OPC UA. So we want to take a moment just kind of explain what that consists of. So when you do OPC UA, you can actually have multiple different security policies. So that can look like a standard OPC UA connection. It doesn't require any level of security. You can do a none security policy. But what that means is you don't have a certificate on either the controller side or your SCADA side. And there's no security for authentication, and there's no security for encryption. So any device will be able to connect, and that data going back and forth between the server and the controller will be non-encrypted. So here you can see a controller without the, let me throw my laser pointer, see if that helps. A controller without a certificate with a no security policy is able to connect to the server, and the data going back and forth between the server and the controller is essentially plain text. It's packaged in a tunnel, but you can see that data. As you move down the line with the security policies, you can have signed data. So what this means is you're going to require a certificate on both sides of your controller to be able to authenticate the controller to the server itself. So you can see here where you have a server certificate on the server side, but not your client side, that connection is going to be rejected. You're not going to be able to connect in that particular configuration. But the good thing about that is if you have a mutually authenticated certificate on both your controller and on the server, and you have your policy set for signed, you can make sure that you have an authenticated connection point to point. Only signed controllers will be able to connect to that SCADA server. However, that is just authenticating the connection. So you'll still have plain text of data going back and forth between the, but you do know that only authenticated device will be able to connect. And then kind of the optimal configuration for that is to have a security policy of signed and encrypted. So what that means is you're able to have a certificate on both the controller and the server side, and the data going back and forth in between is completely encrypted. So not only can only authenticated devices connect to the server, that data going back and forth is completely unreadable to anybody who's not authenticated to have a connection. So that's a huge part when implementing security into your system, is securing the data from the controller to the SCADA, making sure you know who's connecting, and the data going back and forth is non-readable by any other system. Marcus, do you have any comments to how you implemented OPC UA that you'd like to talk to?
Yeah, we're currently using OPC UA Secure, this on and encrypt. We utilize Ignition as well, as you have pictured here, which plays nicely with the controllers.
Yeah, very good. It's real powerful. Marcus?
So on this slide, we just wanted to show that the security is not limited to a local network. It's you can apply these security policies over the cloud, Wi-Fi, cellular, anything, and it's really beneficial. That being said, you want to talk in a little more detail about that, Craig?
Yeah, you hit on all the high points there, right? So really the key is, with the security infrastructure, it allows you to operate on these zero trust networks. So you can go up to the cloud, you can securely lock down your data, really point to point, all the way from your screens, all the way down to your screw terminals and everywhere in between, just securing the data. It doesn't matter, like you said, if you're local or remote, that security just scales completely across the board. Okay, we're also going to talk a little bit about how you're able to seamlessly integrate your field bus devices to communicate with the software tool set, and how it's able to easily implement multiple field bus protocols. So what's that look like? Really, it allows you to secure your network activities, both past and future. So it supports all the latest protocols that you need to communicate with the cutting edge technology for IIoT, as well as it rolls back to your legacy devices. So whether that's SCADA supervisory networks, OPC UA, MQTT, DDS, you have those networks, but you also support both the new and old, your standard DIDO, AIAO type physical inputs, as well as legacy protocols such as BSAP. You have CAN bus, Ethernet IP, Modbus, Profinet, CAN, J1939. The list kind of goes on protocols that can be supported on the CODESYS environment. For all you using CODESYS, this will have the same look and feel that you're used to. It becomes very easy to now implement in the devices into your environment. You just come in, you can right click on your Ethernet adapter, you add a device, and you just choose which protocols you want to add. So you don't need to worry about special modules, just the CODESYS stack supports all the protocols that gets leveraged through the hardware. So with a single module, say on a Bedrock controller, you're able to connect to whatever legacy devices you want. It just really makes the whole process streamlined, efficient, and really easy to configure. Do you have any comments, Marcus, about implementing field bus or supervisory?
Yeah, just being familiar with the CODESYS platform, it's very intuitive, and being able to add the protocol devices. And just a comment on the previous slide, we use quite a bit of OPC-UA and Modbus TCP, and also the HART, the field device HART protocol has really allowed us to standardize on our analog sensors quite a bit, with a lot of diagnostic information, and that's been pretty beneficial.
Awesome. Okay, kind of a segue from what we were just talking about, but you'll continue to see this going forward, is key benefit to Bedrock using CODESYS is that it has a very standardized look and feel with the engineering software. So this reduces the learning curve, but also makes it really easy to integrate if you have previous code sets. One way that really benefits switching between different vendor platforms that standardize on CODESYS is when you come in here, it doesn't matter which control system you're using, this is going to have, you're going to know this environment. So this is going to look similar to you. If you create libraries in CODESYS on any other vendor, you'll be able to very easily switch over that library as long as it's not unique to the hardware, which most of it's not. So you can reuse libraries. If you have just general programs and code sets, you can easily copy and paste over function blocks, do exports, imports, reuse templates. So it really just makes the whole integration between any vendor using CODESYS really straightforward and easy. Really the one that I like the best is the ability to use libraries. So you create a library once, and then you can use that kind of across platforms. Do you have anything you'd like to add, Marcus?
You hit the nail on the head. The library manager in general is very useful. We can pull in third-party libraries from the CODESYS store and utilize those that are proven and work well. Yeah.
Yeah, awesome. Again, leveraging off kind of that previous point and building on that is the ability to do object-oriented programming. This really simplifies the process of reusing code and building on base code and not having to do complete copy and paste and having duplicate code anywhere. So especially as the programs get larger and larger and there's slight variations between different programs, relates really well to vessels that they're all different, but they're all kind of the same. You can use the same base components and leverage those out. What that ends up kind of looking like in the CODESYS environment is you just come into a standard project, you right-click an application, you add an object, you add a POU, and you can choose to do a program, which is a very common thing to do, where you'll just be doing kind of a one-off code write. But more importantly, when it comes to object-oriented programming, is the ability to do function blocks. And then these function blocks also have the ability to do extends and implementation. We'll talk in a little bit more detail of what that actually means. But this is kind of the core component to building object-oriented programming, and it makes it very simple in the CODESYS environment. So what that looks like to be able to extend a really simple program. I made a pump. So what you'd end up doing in this case is you create your, usually referred to as a base block. So you build your base pump that's going to have all the common components that's going to be the same across the board in any variation. So with, say, a pump in this particular case, it's going to have a start and stop. That's pretty standard. You have some fail to start, fail to stop type logic, a little bit of error logic. So that's going to be the same across all pumps. But then you have the ability to extend that logic. And what that means is you're taking that underlying code and you're extending it really with this one block here. You're saying extend pump. So that's extending this code here. And you're calling that code with this single block that says super. So what that ends up meaning is I now have all the functionality of the base pump in this block, and I just added a single interlock. So just by adding really one instruction, I now have two types of pumps. I have my base pump, and I also have a pump with an interlock. And where that really becomes important is when you're testing out code and you have code that's tried and true. Say that you want to change the time of a fail to start or something. You want to make a tweak to the pumps. You don't need to come into both these pump codes and change that. All you do is you change it in the base logic, and that gets extended to the new implementation, and you only change the base code once. And it doesn't matter if you have one type of pump or 1,000 types of pump. You can change that code in the one base logic, and it gets pushed all the way through. Techniques like that are extremely useful when it comes into object-oriented code, not only to simplify building, but also make it more reliable code, because now you don't need to test, say 1,000 different blocks by making one single change. Anything you'd like to add?
Yeah, as a new user to CODESYS version 3, we found this extends functionality extremely beneficial to reduce the amount of code, and it really helps with the maintainability of it going forward. So yeah, we use this quite a bit.
That's cool. All right, coming into kind of our last concept. This one breaks away from our trend of kind of ease of use of programming and similarities, but equally as important is the ability to do redundancy inside the control system. By use of the CODESYS tools, it makes it really easy for Bedrock to implement redundancy. So we're able to have redundancy across the board. So you have redundant power, redundant control, redundant IO, completely, start to finish across the entire system. And it's very simple to add into the CODESYS environment. What that ends up looking like is all you need to do in the software environment is add in a redundancy configuration. You set your path to the two controllers. Once this is downloaded with the redundancy configuration to your control system, this is going to cause the controllers to then synchronize. And now you're running in a full hot swappable redundant configuration. Inside the IDE, you're able to do switchovers. So you can switch over between active and passive. This is full hot standby. So, as soon as you switch over, it's automatically synchronizing with all the values of the previous program, and that ends up switching over completely bumpless. We are going to do a quick demo. Before I jump into that, Marcus, would you like to talk about the redundancy implementation with L3?
Yeah, this feature within the IDE is super nice, especially when you have equipment dispersed through the facility or whatever. It really helps with testing and commissioning, not having to walk to the specific PLC and pull a cable to test that the redundancy works correctly. Super helpful.
Okay, awesome. So I'm going to switch over here into a live demo. I think we're a little bit ahead of time, so I might be able to throw in a few extra stuff, a little bit at cuff here. Maybe, Chris, are you able to confirm what our stop time desired wanted to be here for this presentation?
Take your time. You have minimum 30 minutes if you would like.
Okay, so this wanted to go right to the end of the hour.
Yeah, take your time. it's really interesting to see, and I'm really love to see that you use the redundant. Thanks.
All right, awesome. So so with this extra time, I'm going to jump around into some demos here. Marcus, feel free to jump in, or Raya for that matter, at any point if there's anything that I talk about here that would be good to elaborate on. But we'll show what we have. Let's see. I'm going to go ahead and stop my screen sharing for the time being. Hopefully this allows for a full screen view of the system. Can somebody confirm if the video looks good?
Yes, perfect.
Okay, awesome. Okay, so just to stick to the point with redundancy, we actually have a fully redundant rack set up right here. So what this actually is this is a Bedrock system running CODESYS, which is running redundant power, redundant control, and redundant I/O. In the same way you saw in the IDE, it do quick switchovers. With the program, you'll actually see this is running in the active state where this is running in the passive state. So as we do a loss of communication, you see the control instantly switches over to the new passive, the old passive controller becomes the new active controller. So that data is able to switch back and forth with the full communication between the two. One other thing we like to point out there is because, okay, that's one thing to show that the controller is switching over, but we do also like to show that data is actually being updated. So up here, you'll see that we actually have this redundant I/O running out to a small panel here. We have some digital outputs as well as analog outputs. And this is actually driving a 420 output, which is giving us a triangle wave up top here. So you'll see as the program switches over, you essentially get no blip in your communication, maybe millisecond swap over, and then your program just continues to run. So it doesn't matter when these swap out. It can be loss of communication. It can be switched over in the IDE. It can be loss of power on a slot, pulling a module, doing a hot swappable, doing a firmware upgrade. The system just continues to run. And it doesn't matter if you are going and you lose power off one of your modules, you lose power on any module. So that means if you need to do field swaps of controllers, of power modules, of I/O modules, you need to do firmware upgrades of any of the two. You need to change your wiring, change out power supplies. You can temporarily wire in one of these multi-power devices and do that across the board with redundancy. So with the full implementation of redundancy, thanks to the tools available to CODESYS, you can make a very rock solid system. And as you see, as I made these changes, you never lose your process data. And this is just one single analog output, but it doesn't matter. It takes all your digitals in, digital outs, analog in, analog outs, all your field bus communication, if that's going through a communication module. So you can really make a zero downtime system, on top of the control system. Let me throw in some other cool CODESYS stuff we have going on here. Okay, so time, we have plenty. Another thing that Bedrock's recently done to leverage the capability of CODESYS is we embedded the CODESYS visualization into our controllers. So on top of the controllers itself, it can be, whether it's running redundant, you're doing all these benefits of code programming, you can then use the same look and feel for the web visualization through CODESYS as well. And to show you roughly what that looks like, we have our other side of the room here. And in this case, we have a controller in here running the CODESYS visualization package. And because that's a web server that actually runs on the hardware itself, you can easily come in here and what I like to do is because it's a web server, it just connects by address. You can do stuff such as scan a QR code. This is going to tell you the address of this. It's going to then connect over a Wi-Fi connection, and that's able to pull up custom-built visualizations. That's all done inside the CODESYS software. So you're able to do web server communications with wireless devices. And one additional thing that Bedrock adds to the mix on top of the CODESYS configurations is it adds the ability to do that all over a secure TLS tunnel. So once that's implemented, you can do all these connections, and you can do this again, as I said, in zero trust networks. It doesn't matter. This is just a rock solid communication between it. So extremely easy tool sets to configure, and that all can be done completely secured. In a similar example, this particular one was over a Wi-Fi, but I mean that can be over a cellular modem. This one's running on a cellular modem, and that can be over. This one's particularly running on a long fiber, so this can be on a tablet, or it could be a workstation, or it could be anything that has access to a web browser and is able to connect to the hardware. I know I didn't fully discuss this with Marcus. I'm not sure if L3 has any interest in the visualization or not. So this is kind of a ad hoc question. But do you have any thoughts around the CODESYS visualization, Marcus? Is that anything you've looked into?
We've used it before on previous platforms. I honestly wasn't aware that it was available on the in this version of the IDE. It's good for configuration and stuff like that, setting up ranges of sensors and stuff like that. Interesting though.
Yeah, absolutely. And Marcus makes a great point there. As we like to use this more for like dashboards and configurations. With our IO, it's all software configurable through the CODESYS tool set. So you can extend that into the IEC code, and you can create these quick visualizations that say allow you to do IO checkouts and commissioning while still having your primary SCADA to connect back up to whatever main SCADA server you're using. A huge benefit that you get with that, due to security reasons, is that actually gives you local control access. So a very important thing when it comes to securing your system is that you don't rely on only SCADA connections, one centralized SCADA server to connect to it. That SCADA system gets compromised. Now you no longer have a connection to any of your controllers out there, right? So if this was all on one centralized SCADA server and that connection broke, you wouldn't be able to connect to any of it, right? And that would just take over your process, sets it up really well for ransomware type attacks. But when you use the CODESYS visualization to run a local web server on all these controllers, if you lose access to your centralized server, through the CODESYS visualization, you have local access to each one of these controllers, and you're able to control your process locally. So it's not necessarily meant to be a full replacement for any SCADA servers. You still use your OPC UA Secure, use MQTT, whatever protocol you want for the centralized server. But then you do potentially you can do a localized web server of your system. Okay, and then for any of you not familiar with that, what that looks like inside the software, is it's as simple as coming in, adding a device and adding in a visualization, and you can start to build these visualization screens. So in addition to let's see, in addition to building this in the screen, I think I also have an example up here where, let's see how this works. This is say a visualization screen that we're developing for being able to configure your remote IO racks. So in this particular case, you can have a standalone controller talking to a remote rack, and you don't need to care about getting to making downloads to the program to make those changes. Through the visualization that you pre-configure, you can configure whatever modules are in whatever slot, because all this data is exposed over IEC code. You can build that into visualizations, and they can be both web server, but they can also be local to the IDE itself. So you don't necessarily need to expose this up to a web server. You can control all this in the IDE while you're building your visualizations, and really just simplifies the process. One huge simplification to that is the fact that you don't need to worry about the communications between, say, your local SCADA in this case, and your controller, because it all resides on the controller itself. You know that the data going back and forth between the two is just there because it's all one and the same. And then to that point, and also kind of reinforcing what we talked about with SCADA communications. Here, this is able to have a, at the same time while you're running these local HMI with visualizations, in this particular case, this is running a secure OPC UA connection up to Ignition in this particular case, or any of all the major vendors. They all support the ability to do secure OPC UA. So you have the ability to bring that into whatever SCADA provider you want, and know that this data is secured, and this ends up being your centralized SCADA, right? So this is what most of you are likely familiar with, a centralized server. So you can really do any of these combinations, and the most important thing that we see with the system is being able to make all these connections securely. And I think Marcus would agree is that kind of securing all these connections becomes a very critical part of the system. And from the Bedrock side, the one thing that we add that's slightly different is you have the secured root of trust in the controller itself, so that gets leveraged out to all your devices. It gives you the mutual authentication between both devices. As I mentioned with the secure OPC UA certificate, when you have a certificate on both sides, you can be 100% sure the data is secured between each side. Let's see. I don't know if there is anything, Marcus, you want to add for general other points. I don't want to go too deep onto this demo, but I want to give you a chance to add some if there's anything you'd like to talk about.
I think you hit the nail on the head, covered everything. The secure aspect again is super important to our systems, and it's been pretty easy to work with, considering.
Okay, that all sounds good. What do you think, Chris? Sorry, I was thinking we were more of a 45-minute time frame for this, but if it's a full hour, I can keep on talking about stuff, or we can do something else.
Yeah, it's perfect. Thank you very much. I would really like to have your lab. It's really impressive. And I think, do you have the last words, what you would like to show the last slide?
Yeah, we do have some closing here. So let me switch back to the slide deck. Let's see here. All right, hopefully that came back pretty good. Okay, and then in closing, I think Raya, you're gonna take this deck and just kind of give us a closing summary.
Yes, thanks, Craig and Marcus. Yeah, great presentation. So yeah, I mean the benefits, as we just discussed for Bedrock, hitting all these points, SCADA integrations, OPC UA, what Marcus said is paramount to us. Navy programs, the seamless integration of field devices is wonderful. I mean, having the network cards, be able to take in each individual port, take in multiple different network protocols, because we have to interface to many different third-party controllers, for different engines and propulsion and power management and things like that. And so no telling what's going to be thrown at us, and so we help just integrate seamlessly. So CODESYS IDE is great for familiarization, for being familiar, on other platforms, and rolls in just fine with Bedrock. So and the redundancy is great too. You know, having that seamless redundancy is another big requirement for us, and being able to have that uptime. So yeah, thank you guys, thank you everybody.